Hello everyone, I hope you guys are doing well. In this video, by the end of it, my goal is to leave you guys with enough knowledge to be able to create your own dice cube inside Blender in minutes. It's quite easy, I assure you. So this video is inspired by a cool video I saw on Twitter. It was an artist creating this particular effect inside Maya using its own rigging system. And I thought, is this possible in Blender? Yes, it is. So let's get started and let me show you how I came up with that. So here inside Blender, we have our default cube. If you don't have your cube, you can always go to add mesh cube. Okay, so once we have this, we need to animate this cube because the basic process for this is the combination of the animation constraint, the action constraint, and the transformation constraint. So that's the basic source of this. If you know what I'm talking about, you can keep watching or watch other cool videos on YouTube. But if you want to really learn what I mean by this, you can stick around for this. While we're at it, please give this video a thumbs up if you're enjoying it so far. If you wish to see more from me, hit the subscribe, and please comment on the video. Let me know what you think. Let me know if you have a different approach, probably with geometry nodes. Let's start a conversation. Okay, so let's get started. So like I said, we'll be animating this, and my preferred way of animating object is to have a parent object animate that particular object. I just find this very efficient, and you can dial back things. Also, so we need to set up a parent, and for this I'm going to be using the armature. So now we add our armature, so I'll go here and simple bone. That's going to add it inside the object. To make things easy to see, I'm going to go to the object menu, and let's go to viewport. First of all, I'm going to click in front so we can see through the box, and next I'm going to switch this to wired. Okay, now we can select the box, shift select the bone, and hit Ctrl P, automatic weight. The reason I did this, like the reason I use automatic weight is to allow me to be able to tweak the bone later, because if you have it set with object parenting, you can't really move the bone around because it's going to mess up the position of the object. This is just more of a precautionary measure. If you prefer the other method, it's fine. Any other one will work. So your goal is to just have this cube to be parented to this bone. So now we'll be animating this bone to create animation information to create the procedural system whereby we can move our rig and everything is going to work. Okay, so by the way, I have my shortcut at the corner. You can use it to kind of see the shortcuts I'm using. It's not really complicated. I will also voice it as I go along. Okay, so we need to animate this object on two axes. The first axis is the Z local axis, and the final one is on the X local axis. I will show you the basic ideology behind it, and then I will do the rest myself. Okay, so for the first axis, which is going to be the local Z axis, let's start rotating it. So I'm going to insert keyframes in the first frame. I'm going to move like 10 frames forward. The distance between the frame is not really important. Okay, so I'll move to the next frame with the cursor and then rotate this on the Z axis. And let's go normal. So you can switch it here from global to normal. So I'm going to rotate it on the Z axis, negative, rotate say 45 degrees. Okay, so we have that, and let's rotate it Z 45. And we do that one more time, rotate Z 45. So basically we want to get like a full revolution. So rotate Z 45. Rotate Z 45. Okay, two more. Rotate Z 45. Rotate Z 45. And finally rotate Z 45. Okay, so if we play the animation, everything should look like this. So it's a full revolution of it rotating. So the next, I'm going to switch this from normal to global, because I want to come here in the breakdown and move this to make sure it's always sitting on top of the grid. So we can do it every center to give it that cube feeling of it's always staying in flat surface. It's quite important. Okay, so we should get something like this. You can even refine it more by going in and adding more keyframes to make sure it's always staying flat. So you can always move this, that every single point we're not getting any penetration through the floor. Okay, so let's move this. We're almost done now, guys. And finally, this. So we should get its always maintaining its surface area. Okay, so this is the first animation and that we're using to apply to the constraint. So I'm going to pause the video now and do the rest and come back once I'm done. So I'm done animating, and we can see if we play it, this is the final axis on the X axis. Okay. So as you can see, but we want it to keep going forever. So we will select all this keyframe and go to channel, go to extrapolate mode and make these cycles, make cycle F modifier. So it's going to add a modifier on the keyframe, on the curves to make it keep going forever. So we should get this, and we're currently not getting that. Let's repeat that. Extrapolation, make cycles. For some reason it's not working. So for the previous ones it worked. For this, for some reason it's not working. That's no problem, we could add it manually ourselves. So to add it, you just come here, select the curve which you want to add it, go to modifier and click on the cycle. We'll repeat it here, cycle. So basically that script earlier of make cycle is just basically adding this modifier. So you want to go in, you can just select one dot and click on cycles, and we should get it going on forever. So like I said earlier, the position of the keyframe doesn't matter. You can make it fast or not, and it's fine. So let's make sure everything is saved. So you have to click on this, so if you restart Blender, your animation data is still going to be there. Okay, so we are all set to start adding the constraint. So for the driver for this animation, we need just one controller. So let's add that controller. So we could duplicate this and move it on the Z axis. So this will serve as our controller object. One way of adding constraints in Blender is to select the object which you want to apply the constraint and go into the constraint tab and select the appropriate constraint. A cool shortcut in Blender that you might know or not know about is if you select the controller and select the object which you want to apply the constraint and hit Ctrl+Shift+C, it's going to bring this menu and you can select this constraint which you want. The great thing about this is it's going to input all the necessary informations like the bone, which the exact bone which you need, especially if you've not named your bones. This is a very optimal way to add your constraint. Okay, so we've added the constraint, and if we move the controller object, nothing is working. That's because we need to set our parameters. Since we want the animation to go forever, the range can be 1000, so we can set this to 1000 and the start frame 1. So let's select the first animation which we want to drive. So the first animation we're looking for is the Z positive. So we can cross-check that by bringing this out and see where it's going. So it's rotating its direction. So basically we want, when we move this on the X-axis, it will rotate. As you can see, it's slightly working. We just need to finish setting it up. Okay, so I'm going to select this object and switch this to local space, X location. So the controller object, if it moves on the X location, then the animation is going to work. For the max, it's basically how fast. If you set it at 0, you can get like a snapping object. You can get it just snapping. That's because it needs more range. So I'm going to set this to 200 because I think this kind of work in tangent with the frame. So if you have more frames, you usually want to have longer duration time. So you can see it's rotating anytime we move it this direction. Okay, so we want it to work when we move in this direction, not this direction. The way to flip that is to just add a negative in the front of the 200. So if we move this, it's going to keep rotating. If you want it to rotate faster, you just need to reduce it like negative 100 and you get a faster revolution. So I found maybe let's go in between negative 150 should do the trick. So for the rest, it's just a matter of coming here and duplicate, and let's switch the animation to Z negative and just switch this to 150. So if we move this direction, it goes that way. If we move it this direction, it goes this way. Okay, let's do that for this X axis. So we'll select this, duplicate, and we can name this. We can select when it moves on the Z location, local space, we get the positive X rotation. So when we move this like this, we get it working. Okay. And the great thing is you can combine multiple at the same time. So let's make sure we have everything set. Not the object action. Anyway, let's keep going. And finally, we'll duplicate this and select the appropriate one, which is going to be, that's what we have here, negative, positive. So we select the X negative and also set this to negative 150. So if we move in this direction, it rotates. If we move this direction, it rotates. So as you can see, we can have it spinning around now. It's combining the whole animation that we have working. So for the final touch, we want, for some reason, I didn't get why it's doing this. Okay, so the reason for that is nothing to do with the constraint. It's basically the animation. So I just needed to make sure it was zeroed out in the first frame. That fixed that. So you want to make sure your first frame is the default pose and your last frame is the default pose. Okay, so we have everything working as it should. We have it going nicely here. It's kind of taking time to start. Let's see if we can fix that. So it's 0. Okay, so it's working as it should. So for the final step is let's do the transform constraint. Basically, when we move the control object, because currently when we move it, it's just rotating. We want it to actually move, translate. So to do that, we can use that optimal way of adding constraints in Blender. We'll select the control object and select the object you want to apply the constraint to. Control Shift C, and we'll be adding the transformation constraint. Okay, and the transformation constraint is I think one of the most robust constraints in Blender. You can see it has some settings which might look intimidating, but I'll try to do a good job in making it easy to understand. So you have the typical stuff which you see in most of Blender constraint, which is the target and owner. By default is set to Workspace. Workspace basically is more useful for object, since like in Blender you have the Z-axis as up, where in most typical packages the Z-axis is the depth. So Blender Bone System uses the right 3D orientation, and to make it work with it effectively, you need to switch this to local space. So it's going to respect that axis. Also, there's a cool new addition to Blender, which is the local space with owner's orientation, which I will try to talk about some other time, but it's a pretty cool stuff that definitely increases the power of Blender constraints. Okay, so this is a typical stuff you can find in most of Blender constraints. The next one is the extrapolate. So this extrapolate is basically like enabling a loop system. So by default, without it, if you want an object to do something, it's only going to happen once. But if you have this extrapolate, it's always going to keep working as long as the action which triggers emotion is being carried out. The action, the desired result is always going to keep happening, kind of like a loop system basically. So once you have that check, which we need for this instance, so we're going to enable that. And then the most important part is this map from and map to. Map from is basically the action of the controller object, and in this situation this is the controller object. So we want, when we move this on the positive, sorry about that, that's just my alarm to drink water. So we want, when we move this on the positive negative x axis, we want to get we want that action to drive a certain effect. So for that, let's select this. So basically we want this to move on the x, so we set this to -0.1 and set this to 0.1. Okay, so when we move -0.1 meter on the x-axis, it's going to carry out an action. Likewise, when we do it on the negative and positive axis, it's going to do the same thing. So you can apply the same to your mindset onto the rotation, the scale. Though with rotation, you're dealing more with degrees. With scale, you're dealing with Blender's scale unit. And now for the map tool is basically the action you want your object, the receiver of the command, to perform. So basically in this instance, we also want it to follow the movement of this. So we want, when this is moving on the x-axis, this also moves on the x-axis. So let's set that up. I'll set this to -0.1, -0.1. Okay, so now if we move this on the x-axis, it seems like nothing is working. So it happens sometimes. Let's make sure we have everything good. Oh, sorry. So we set this to 0.1. So negative, positive. Those, in some scenarios you might want to switch them, but in this case, by default, it works. So you can see now, if we move this on the negative axis and positive axis, it behaves as expected. If this is rotating faster, you can always adjust this max influence here. So as you can see, this is what we have working. So let's repeat the same thing on the local x-axis. So the reason the way you can confirm the axis which you're working on is if you bring out if you click your spacebar, you bring out your move tool, you can see that this axis are color coded. So if you look at the blue, you can see it's the Z axis. If you look at the green, it's the Y axis, and the X axis. Okay, the red, sorry, is the X axis. If you switch it to global, it changes because it changes because they're using different orientation. But typically, when you're working with armature, you always want to work in the local axis because it gives a more accurate representation of the axis. Okay, so let's do finally for the local Z axis. So I'm going to duplicate this, and all we need to do is to just switch the parameters. So like we did for the x-axis, so we know that when we move this here, so we know when we move this here it works. So we want, when we move this direction, it does the same thing. So let's just set that up. So in the z-axis, we'll do -0.1, 0.1, and here we'll do -0.1, 0.1. So now if we move it this direction, you can see it rotates. So that's basically it. So you can always hide this in another layers. So you just have this visible. So or what's left is for you to apply like a cool texture or kind of model the dice cube which you want. So that will be it for this tutorial. I hope you guys enjoyed it. If you wish to see more from me, please hit the subscribe button, and as I mentioned earlier, please comment on this video. I am going to put this file available for download, so if you wish to use this to practice, it's going to be available for you. So yeah, thank you for watching. Bye bye for now. See you next time.